Okay, everybody. Let's start today's lecture. Okay, we have good size. Today we will continue from wherever we left. Last time we have seen this program. Okay, so I'm just trying to remember what I put on here. It was too crowded slide. So we talked about C++ being a strongly typed language and everything. And we talked about the differences between the cout and printf and C and scanf. And we talked about adding two integers, and I gave you an exercise, right? And we talked about operators, a lot of operators. And then we compiled our first program. We looked at the menu page of the G++ compiler. There were many.
Professor, your microphone is muted now. Could you hear me?
Okay, thank you, Ilhan. So last time we talked about this program, this small program, and we said that it is our first program, and we talked many other things. Actually, we talked about the differences between the printf and cout, and then we talked about the scanf and cn, and we talked about operators. We talked about adding two binary numbers and finding the algorithms for it, etc. Then we talked about the compiler options, and then we looked at the manual page of the G++ compiler, and we continued, and we said that variables identifiers, the way we use identifiers in C++ and C is the same. And for the identifiers, we should use meaningful names and etc. And then we talked about this. I think this was the last topic that we talked about. Types of data types. And these are very similar to C. There are a few new types. Short, we had the short already in C. It is just 2 bytes. Integer is 4 bytes. Long is 4 bytes. Float is 4 bytes. Double is 8 bytes. And largest and smallest numbers are etc. They are all there. Okay. So the new type here is the bool. Okay. Bool is for Boolean. In C++, we don't use, for the if and while statements, for any logical expression that requires true and false, we have a new type named Boolean. It can take two values, true or false, and nothing else. Remember in C, we used to say if 0 or if 1, okay? We don't do this in C++. They are both still valid. They are both still valid, but we don't use them. Instead, we use these Boolean values. If you like to do something like this, if 0, what would you do? You would do if true. True and false are two new keywords in C++. And whenever we can use them, we are going to use them, okay? We don't like to use integers inside our if statements or while statements or for statements. We like to use Boolean expressions. And the last time we talked about this important note here too. In this table, display 1.2, okay, this is copied from your book. These values, like 1 byte for the Boolean, 1 byte for the character, 10 bytes for the long double, they are only given as examples. They are not necessarily the values that your compiler is going to provide, okay? Because C or C++ doesn't guarantee you the size of the type variables that you're going to use, okay? They depend on your compilers, operating systems, your environment, etc. Okay, so it may change from one compiler to another compiler, or one operating system to another operating system. Okay, C doesn't guarantee that your double will be 8 bytes or float will be 4 bytes. These are not guaranteed. But if you like to make sure that your doubles are 4 bytes or 8 bytes and etc., instead of using the regular double, okay, you would use I'm sorry, not for the doubles, but for the integers. You would use these types, okay, C++ 11 types, okay. These are C++ 11 types, and when you use them, if you use this type as an integer, it is definitely 8 bytes. There is no other way. This doesn't depend on the compiler or the operating system. Okay, so I think this was the last point that we made, and we stopped there. Now I can ask you if you have any questions. You have any questions? We assigned your first homework. It is on Moodle. You have 10 days. It's a simple game programming homework. And we will continue working on this homework. Okay. Working on this game. Okay. Every time I assign a new homework, it really doesn't depend on the previous homework, actually. I mean, you can do homework number 2 will be about this homework too, this game hacks too, but you can start from the scratch and you will have enough time to complete it. You don't have to use your previous homework's results. That's what I mean. Okay, if there are no questions, then I will ask a question. I will pick your question from the list, and that way I'm taking the attendance too. Just okay. Muhammad Ali Shenojak. Muhammad Ali, are you there? Muhammad Ali, tell me how you would learn, how you would know the size of your, let's say the size of your long double, or the size of your, let's say, integer on your system. It says it is 4 bytes here, but Muhammad Ali, are you there? Muhammad Ali Shenojak. This is kind of attendance, okay?
Hocam chat'te yazıyor.
Muhammad Ali Shenojak, okay? I am asking you a question. Are you hearing me? Muhammad Ali, are you hearing me?
Hocam sanırım mikrofonu yok. O yüzden chatten yazıyor.
Muhammad Ali, I asked you last time to fix your microphones. Okay, I need your microphones. I need to talk to you. Okay, your answer is size of. Size of is an operator, yes. Okay. And the other thing is that I cannot see your faces. Please, everybody, at least put an image of your face as your logo in Teams, okay? All I am seeing is the letters. Enis Yalçın has a nice picture. Okay, everybody put their pictures in their Teams profile so that I can see your faces.
Tamam.
Okay, so what Muhammad Ali says is correct. Size of is a operator. Okay, size of is an operator, and when you use it, it will tell you the size of the variable, or size of the type that you wanted to learn. Okay, so as I said, this is not a function, this is an operator. Okay, this is not an operator, this is not a function, because if it were a function, then you cannot send a parameter like int to a function, right? If f is a function, I may send a variable to function a, or I may send a value to that function 1.2, but you cannot send an integer to a function like this, a type name. Okay, if it's a function, so this wouldn't be possible, but with operators it is possible. Okay, good. Let's move on then. Let's continue. C++ 11 has some new types, other types. So for now, we have learned that bool is a new type. There are other types. Okay, one is auto. Okay, auto says that I have when you say auto x assignment operator and expression, it says that I have a new variable, its name is x, its type is automatically will known. How? I will give you an expression, whatever the type of that expression will be the type of this x. For example, I could say this: auto, okay, auto I, for example, 7 plus 5. When I say that, okay, when I say this, I will be an integer. Why? Because 7 is an integer, 5 is an integer, 7 plus 5 is 12. So I will be an integer and with the initial value of 12, okay? You might say that this is not a very good idea, because instead of saying auto I 7 plus 5, I could immediately say integer I 7 plus 5, right? But sometimes this is very convenient. For example, when you say things like auto I, let's say I have an object named v begin. Let's say v is a new type that I don't know. Begin is a function, and I actually don't remember the return type of this function begin. Okay, if I don't remember it, this is convenient that I can do. Okay, just say that whatever begin returns, whatever that begin returns, I will take that type as a type for this I. Okay. The book says that it is useful if we have verbose types. What do we mean by verbose types? Type is so long. I mean, when you type the name, for example, vector member function begin. If I could find it. Okay, this is good. Let's look at this C++ thing. Okay. So this begin returns this const iterator type. I don't want to type in here. I don't want to type in here std. Okay, this is the equivalent statement in C++ if you don't want to use auto. Std, okay, vector const iterator I v dot begin. I don't want to type this whole thing. Instead, I say auto. Okay, so auto is useful. It's a new type. Auto is a useful. Auto is by itself is not a type, but it's a way of deducing the type of the variable. Okay. Similarly, declaration type is another way of deducing the type of a variable. For example, x times 3.5, whatever the type of that is, it is a type of y. Okay. It is a type of y. Okay, so two things, auto and declaration type. We will use them whenever they are convenient to use. Don't try to always, don't feel that you are required to use them all the time, but whenever they are suitable, convenient, just use them. Okay, good. Assignment is very similar to C plus C. Okay, in C++, assignment is very similar to C. Two ways of assigning data. One is the initialization. The second one is the regular assignment. So when you declare a new integer, when you say int my value, initial value is 0, okay, that's called initialization. It's a type of assignment. Okay, it's not a regular assignment. It's a specialized assignment because you use this assignment procedure when you are declaring your variable. You say that I have an integer. Okay, its name is my value and its initial value will be 0. Okay, this is one. The second one is assignment during the execution. Okay, for the assignments we use the assignment operator. This is not equal to operator, this is assignment. Okay, don't read this as equal to. Okay, when you say a gets the value of 2, this is an assignment. You don't read this as a equals to 2. This is not equals. Okay, when you say a gets the value of a plus 1, if you read this a equals to a plus 1, that's definitely wrong, right? A is not equal to a plus 1. It cannot be. Okay, so the correct way to read is a is assigned a value of a plus 1. A is assigned a value of a plus 1. A gets a plus 1. Okay, so when you do the assignment, it's an operator again. When you do the assignment, there should be some stuff on the left and some stuff on the right. Whatever can happen on the left, they are called L values. Okay, it's an L value. And here is R value. Okay, for the L values, we have variables. Okay, you could say A is an L value. Okay, another variable L value. For the R values, it can be an expression. Okay, so this is an expression, it's an R value. This is an expression, it's an R value. Or this is an expression, it's an R value. Okay, so in this case, distance is an L value, rate times time is an R value. Okay, for assignment, on the left we have L values, on the right we have R values. Okay, on the right we have R values. If you like to view this as a set of stuff, the set of L values is a subset of all the R values. Okay, what we have in the L values, we have variables. Okay, as the R values, we have variables, constants, right? Constants and expressions. Okay, so R value, the set of R values is larger. Set of R values is larger. It is okay to have statements like A gets the value of 7 plus B. This is an expression, right? This is a variable and expression. This is okay, but this is not okay. 7 gets the value of 1 plus B. This is not. Why? Because this is not an L value. Okay? This is not an L value. This is an R value. This is an R value too. Okay? So this is not okay, but this is okay. So assignment is a very important operator, okay, for our case. Very important operator. And we are going to use it so often. Don't read it wrong. This is not A equals 2. This is A gets the value of 2. A gets 2. And be always careful about what could be an L value and what could be an R value. Your G++ compiler will produce messages, error messages, saying that this is not an R value, this is an L value, and know what the compiler means by L value and R value. Okay. Remember, I asked you a question previously. I said that instead of this operator, 1 plus 2, instead of using this plus operator, I said add integers and it will take 2 integers. And you came up with an idea how to implement this add integers, 2 integers, without using the plus operator. Okay, without using the plus operator. So I'm going to ask you the same question again. How would you implement this operator? A gets the value of B. Okay, so I'm going to, of course, this is going to return an integer. How about this? Assign integer. So what kind of parameters would it take? What would be the parameters for this assigned integer?
Using pointers.
Pointers maybe, but I don't think that we will need 2 pointers. Maybe for the first one I need a pointer, an integer pointer, right? For this left side, L value. For the right side, I just need an integer, right? And what would this assigned integer return?
A Boolean or true or false.
It will return what?
And we return Boolean over true.
Say it louder, I cannot hear you. Bora, are you talking?
Yeah.
So say it louder, what are you saying?
If you want, we can return a Boolean or true or false, or we can just return those.
I don't understand what you are saying. Your voice is so... Repeat it again. It will return what? Okay, somebody else. It will return what?
I think in this case we don't need anything to return.
That's not a correct answer. No. When we say A is assigned B, assigned C, assigned D, this works, right? So this one should return something so that I can assign it to B, and this one should return something so that I can assign it to A. So this one should return something. What should it return?
D or 0?
What?
D or 0 in this case?
Or 0? What do you mean 0?
0, just 0. For the take all D values, 0.
What should I write here? In this case, I write int, right? What should I
It
put?
should be int again. It should be an integer.
It should be an integer, right? It should return an integer. Okay, so how would I implement this function? Because I don't have the assignment operator now, right? Tell me how you would implement this function. You don't have the assignment operator. Hüseyin Ömer, I don't know, zero pipe int, is that an implementation? I think you are answering my previous question. So how would you implement this function? You don't have the assignment operator. Hüseyin Ömer, could you use your microphone and tell me what you mean? I don't understand what is 0 or int. Int is a type. Int is a type, okay? You don't pipe, you don't or logical or 0 with an int type. So what do you mean?
Int means the number. I don't know. Just in this case, just D.
So what kind of an assignment is that? I mean, how would I, okay, let me start from the beginning then. Here, I am saying that, okay, instead of doing this, I like to do this. Assign integer a b. Okay. So at the end of this function call, I want the value of a changed from whatever to the value of b. So how would you implement this?
Copy the value at B and paste it into the memory of the pointer, that a pointer.
Exactly. So how would you what would you write here?
Sir, why do we need pointer in A? Because we will return integer.
Because we are going to change the value of A. If I don't send the pointer in, I cannot change the value of A.
But we will return something from assign integer function.
Yeah, then we will deal with that later. But there needs to be a way of modifying the value of A, right? Because this is an assignment. At the end of this assignment, the value of A is going to be changed. Okay? In our previous example, when I say A plus B to add int A comma B, in that case we did not change the values of A or B, right? We just used their values. In this case, I am going to modify the value of A, not B, but A. So I am sending the address of A so that I can modify it. So I assign int, let me write it in a better way. Okay, let's say this is L value and integer R value. So somebody said about Kadir Chankaya. Okay, Kadir, could you use your microphone again? You are using the assignment operator. To do the assignment, you are using the assignment operator. You are not allowed to. Muhammad Ali, okay, Muhammad Ali. Just use your. You don't have the microphone. I am not reading your messages anymore. No, you just tell me using your microphone. So how would you? Okay, this is an exercise for you. Okay, next time I will ask you how you would implement this assignment operator, and you are gonna tell me, using your microphone. Okay, so assignment is something like this. As always, operators are like functions, but they are specialized functions, and we can always implement them using functions. But again, this is not a very nice way of. Instead of writing this, I wouldn't write this. This is much nicer to write and read than that. This is much nicer to write and read than this, right? Okay, so and I will ask you later how to implement this one. Okay, let's move on from this slide. There are some examples here, and these are shorthand notations. You all know these. Again, these are operators. These are operators. These are all operators. Okay, if you have the addition operator, it is easy to implement this one, and you all know they are all equivalent to this one. Okay, increment the value of count by 2. So instead of typing count 2 times, I just do this, right? Okay, good. So for the assignment rules, the rule is don't use type mismatches. Try to use the same type in an assignment or in an expression. Okay, if variable is an integer, don't do this. Okay, don't try to assign a double to a integer. Okay, so this is not a good idea. Don't do that. Okay, if you have an integer, integer a 7, this is nice. If you have a double d, just do this 1.0. Okay, don't do this. If you have a double d2 1, don't do this. No, you might say that it is the same thing. Well, yeah, it is the same thing, but this is better. Instead of saying this, okay, do this. Oh, sorry. I'm sorry. I didn't mean that. Double and double. Yeah, if you have a double, initialize it with a double. If you have a double, don't initialize it with an integer. Initialize with a double. You might say that this works too, but yeah, this is true, but this is a better way of doing it. This is more readable. Okay, there is no confusion. Okay, since there is no confusion with this one, okay, okay, always use this one. Don't use it that way. Or this might work too. I mean, when you say 7.2, I don't know what would be the initial value of integer, but it will work. It will compile. Some compilers will give you a warning message, maybe. Some compilers will not. It will make an initialization, but don't do this kind of stuff. Okay, always do always use the same type into an expression, okay? General rule, cannot place value of one type into variable of another type. In your expressions, always use the same type expressions. Okay, literal data, they are called literals because you literally type them, okay? Sometimes we call them constant data, but we don't want to call them all constants. These are constant, but these are literal constants, okay? There are other type of constants. Okay, there are two types of constants. One of them is my pen is acting up again. I think I need new batteries. My batteries are on their way. Okay. So one of them is literal constants. Such as this and this and this and this. These are literal constants. The other ones are named constants. Okay. Named constant is something like this. Let me give you an example for a named constant. Okay. Constant integer size $10. Okay. So this one is a named constant. Okay. This one, 7, is a literal constant because I literally typed it. Okay. So these are all literal constants. An integer, a double. Well, this one says it's a character, but it looks like they typed it wrong. It should be single quotes, right? Z. And this is a constant string. Okay, good. So these are, there is not much difference from C. Okay, they are all very similar. Okay, escape sequences are there too. I am not going to talk much about them, but with the escape sequences in a string, when you say n, okay, this is not a literal n anymore. This is an escape string n. It means new line. Okay, question. How many characters are there in the string? How many characters are there in the string?
One.
One character.
Well, if you don't count the terminating character, the null character, yeah, it is 1, but if you count the terminating character, so this string occupies 2 characters in the memory. One is this character, new line character, the other one is the null character, right? Okay, that's it. So this is a string. Also, this is a character, right? So this is a new line character, carry, return, etc. There are many escape sequence characters, and you know all of them or some of them from your C course. I will not talk much about them. Okay. So these are the examples. They are all valid for C++ too. C++ has a new row string literal. For writing string literal constants, they call it row string literals. They have this syntax. String is a new type. Okay. It's a new type. String is a new type. And with the string, you can do most of the things that you can do with the character arrays. Remember the character arrays in for C. String is a type something like that. Okay. String is not part of C++. It comes from Okay, to be able to use the string, you need to use include string. Okay, it's a new type, but it is defined inside this library. Okay, you may use this notation for a raw string. Okay, it has to start with a big the uppercase letter R and the quotation mark and the parentheses and whatever is inside this. Okay, inside this part. Okay, it is assigned to the string S. Okay, no backslash characters will be interpreted as escape sequences. I mean, it is exactly this string. Backslash T, backslash T, and backslash N. Okay, so there are no escape sequences. There cannot be any escape sequences inside this string, raw string. So this is a new way of defining a. This is a new way of defining a string in C++. We may use this time to time. Okay, good. Let's move on then. Okay. Constants again. Let's return back to constants. Remember what we said? We said two types of constants: literal constants and the named constants. Okay. Sometimes we need to do this. I have a variable named number of students. Its initial value is 24. Okay. Variable named number of students, its initial value is 24. I know it's an integer, but I know that number of students will not change in my program, so I make it constant. Since I make it a constant, you cannot have a variable constant, right? Variable means it is going to vary. It will change its value, right? Constant means it's not going to change it. So we don't call this a constant. We don't call this a variable. We call it a named constant. Okay? Declared constant or named constant. That's why we have two types of constants. Literal constants. This is a literal constant. This is a named constant or declared constant. Okay? And you know that in C, instead of doing this at the beginning of the file, we do stuff like define size in a minute it will work. Okay. Okay, reinsert the battery. Define size 10. Okay, in C we used to do this, but in C++ we don't do this. We do it this way: constant at number of students 24. Okay, so what would be the difference? Well, there is not much difference. You may use it this way or that way, but in C++ we prefer using named constants. Okay, we prefer named constants. Why? Because I know that the programmer is telling me, as a compiler, I know that the programmer is telling me that number of students is an integer. Okay, in this case, what is the type of size? I mean, there is no type of size. It says that whenever you see a size, replace it with 10. Okay, whenever you see a size, replace it with 10, and 10 is an integer. So in a way you are saying that it's an integer, but this is explicitly saying that the type of number of students is integer. Okay, so we are not going to use this kind of constants anymore. We are going to use named constants or declared constants. Okay, here is a very simple program from the book. Very simple program. Let's read it. And this one uses named constants and a few statements that we have seen so far. Okay. IO stream for using C in and C out. Okay. Using namespace, standard namespace, we'll talk about this. Okay. So line number 6, I have a named constant rate. Initial value is 6.9. Okay, this is going to be a bank interest calculation example. Line number 7, double deposit. So deposit is a double. Okay, and its initial value, I don't know. So it looks like I don't care about the initial value of deposit. Why? Because I am going to make this initialization. I did not initialize deposit. It is okay in this case. So I am writing this to the screen. Enter the amount of your deposit. The user enters a value. I get that value as a double and I put in deposit. Okay. And then I have a new variable, a double variable, new balance. Okay, we didn't have this before in C. Okay, in C, all the variables are declared. All the variables are declared at the beginning of the block, either function block or whatever block that you may choose. Okay, in C++, you may declare your variables wherever is suitable, wherever you need them. Okay, at line 10, I am declaring a new variable, new balance. Okay, and I get the value from the user. I divide rate by 100 and multiply it with deposit and add it to deposit. So it's an interest calculation and assign that value to new balance. And I use the cout statement. Cout, in 1 year, your deposit will grow to this much money. C, this is a string, another string, a double, another string. So the stream insertion operator is smart enough to handle the type of the parameter. Okay, but I don't like this 100 here. I think it should have been 100.0, right? So that rate is divided by a double. Rate is a double, deposit is a double. We prefer not mixing doubles with doubles. Okay, we prefer not fixing doubles with doubles. We prefer using doubles with doubles, not mixing doubles with integers. Okay, so if I compile and run it, I will ask the user, what is your deposit amount? 100. And if the interest rate is 6.9% for a year, so at the end of the year, your deposit will grow to $106.90. This doesn't look good, right? You wouldn't say $106.09. You would say $106.90, right? So I need some kind of a formatting, and we will see the formatting in a few minutes. Okay, any questions so far? Any questions?
Can I ask a question?
Sure.
Can we change the value of constant variables by using pointers?
Well, you could actually. I mean, in C, I mean, this is not of course, this is not suggested. You are saying that can I take the address of rate, right? Can I take the address of rate and assign it to something and later I use that value to modify it? Well, there are ways of doing it, but C++ doesn't suggest you to do those kind of stuff. Remember our void pointer P. Okay, so void pointer can take any kind of pointer type, and using this, now I have my pointer pointing to a rate. Maybe I can assign it to a non-const double and change its value. It is possible, but they say that don't do that. Okay, nothing will come out good. Nothing good will come out of it if you do that kind of stuff, because you are saying, as a programmer, you are saying that it's a constant. Now you are trying to change its value. That would be very, very confusing. Okay, that would be very, very confusing. Question for you. Okay, question for you. This program, okay, it's a very small program, like 15 lines of code. What happens if I erase this keyword const from this program? Okay, just I erased it. Would it compile? If I erase that const keyword from line number 6, would it compile?
Yes.
Yes. Would there be any logical error in my program? It would produce me exactly the same thing, right?
Yes.
So why am I using that keyword then? I mean, if it is not good for compilation, if it is not good for any logical errors, why am I using that const?
You will guarantee your program.
I guarantee my program. Just explain it a little bit more, Osman.
I don't know. Maybe there is a error.
Well, I know there is no error in this program, right? It runs and compiles nice.
If somebody else uses the program, it can change the rate easily.
Say that again.
If anybody uses the program or want to change the rate, he can.
Well, I mean, if either somebody else or myself, let's say after 6 months, I take this program back and I'm trying to modify it, and by accident here I said that now rate should be maybe 5.2. Okay, if I do this later by mistake, the compiler will tell me that this is not okay. Okay, it's going to give me another message. Okay, that's why I use const. I use const for myself as a programmer, as a human being. I don't use const for the compiler. Okay, this plus is important for the compiler. If I don't use this plus, okay, if I don't use this plus, my program will be wrong. Okay, but if I don't use that const, my program will not be wrong, but it's a good way of preventing possible errors, because I know that rate is not going to be changed. Okay, it shouldn't be changing. That's why I use const. So back to Atakan's question, is there any way to change the value of const? Yes, you could change the value of const. Okay, a const variable, a const named constant, but that don't expect anything good out of that. Okay, because const is there for the programmer, for you. Okay, if your intention is changing the value of rate, you are making either one of these mistakes. Either rate should not be a constant, or when you wanted to change the value of rate, your logic is wrong. Okay, if you need to change the value of a constant, then your logic is wrong. Change that logic. Okay, good. Let's take 10 minutes of break. Now it is 11:27. We will be back here 11:30. 37. And think about, where is my question? I asked you a question, right, somewhere. Where is my question here? Remember I asked you, how would you implement the assignment operator? When we come back, I will ask you that question again. And I will fix this stupid thing, okay? Okay, be here in 10 minutes. Okay, everybody, let's continue. I just took the attendance. Okay, so we talked about const. Somebody asked a question about can I change the const? Of course, you can. I mean, if somebody tells you that you cannot do this, compiler will prevent you. There is always a way of working around that mechanism in C or C++. Everything is possible in C. You may do anything you like because this is your compiler. And if you cannot do anything, the worst thing is that you could go to the generated assembly file and make your changes in the assembly file. It is okay, but usually those kind of changes are not good for you as the programmer because you are doing something that is unintended. Okay, this is not a safety issue. I mean, it's not because the compiler is trying to keep something safe from some bad people. Okay, when you say it's const, it is possible to change it later using some tricks, and those tricks are not that difficult tricks. Okay, so if you do that kind of thing, you are going to hurt yourself, not somebody else. That's what I meant. Okay, so did you find the solution for the assignment? Somebody tell me the solution for the assignment operator. Anybody find the solution for the assignment operator?
Hocam A'yı B'ye atıp sonra A'nın pointerını return etmeyecek miyiz?
Just tell me in English. Who said that? I don't know. Enes, was it you? Enes in English. So Abdurrahman Arda is give me it say that just stuff from A to B, then size of B. Yeah, that might work. What? Arda, why are you returning either 0 or 1? You should return the value of B. Whatever you pasted is okay. But why are you assignment operator? When you do the assignment A, B, C, what does this do? Arda, where are you? Just talk to me.
I checked.
You check what?
Is assign happened or not?
You should return just B, okay? Return B. After the mem copy, return just B. Because in that case, just to be able to do something like this, what was the assign int, right? I will assign A, the result of assign integer B, C. Okay, and another parenthesis here. Okay, these two will be the same. Assign the value of C to B, and then whatever is assigned, assign that value to A2. Okay, so are there any solutions without using the memcopy? Don't use memcopy. What would you do? I would take both addresses and assign them to a character, unsigned character pointer, and I would, in a loop that goes from 0 to size of B, and I do the assignments one by one myself, character assignments. That's how the memcopy works, right? So the assignment operator is not a magical operator. It's an operator. All it does is it takes a value and assigns it to some memory location in my memory. Okay, good. So arithmetic precision, we all know this from C. We know that this is 3, right? Because it's an integer division. This is 3.4 because 17.0 is double. This is an integer. The compiler doesn't know how to divide a double with an integer. So what does it do? It says that I will produce a new double whose value is equal to this 5. So it makes a new double whose value will be 5.0. Now it has 17.0 and 5.0. It knows how to do this division. Okay, it knows how to do this division. Again, this is an integer division. If the value of integer variable 1 is 1, integer variable 2 is 2, this over this is 0 because 1 over 2 is 0 in C or C++. Okay, so these are some of the details that we should be aware of from our C course material. Okay, sometimes it gets tricky. You might think that since there is a double, all of them will be converted to a double. No, which division is going to be done first here? Okay, out of these divisions, division A or division B or division C, which one is going to be done first?
A.
Division A is going to be done first. Why? Because of what? Because of the
assignments from left to right.
This is not an assignment, this is a division.
Divisions, I mean.
So because of the associativity rules, right? There is this the priority rules. Priority rule says that plus and minus will be done after multiplication and division. It says that, but what happens if I have multiplication and division on the same line? In this case, the associativity rules says that you're going to do it from left to right. So this one is going to be done first, 1 over 2. The compiler says that this is integer, so this is an integer division. A is an integer division, so this one will produce 0, right? And then B is going to be done 0 over 3.0. Well, 3.0 is a double, 0 is an integer, so let's make a new double out of this 0. So it will make a new double, 0 over 3.0, it is 0 again. So this one will produce 0.0. Then after that, C is going to be done. 0.0 over 4, again, another conversion. It will be 0.0 again. So the result of this whole thing is 0.0. Again, I will come to the same conclusion. Don't do this kind of stuff, okay? If you want to do double division, then do this. Much clearer. If you want to do the integer, then don't use this. Okay? So this is individual arithmetic precision stuff. You already know this from C. Sometimes, remember this, we said that sometimes things are converted for us when you do this kind of stuff. When you do 3.0 over 2, double integer, something has to be changed here because integer operator cannot handle this. So I will make a new double out of this 2. Okay, so this is called casting. Sometimes this casting is done automatically. Okay, automatic casting. This is an automatic casting. Sometimes we like to do this casting ourselves. It's called typecasting. Okay, for example, if you have an integer variable, you like to cast it to a double. So you use this new operator, okay? Static cast double. This operator will make a new double whose value is equal to this integer, int var. Okay? This is a new operator. Again, it's an operator. Okay, and it will take a new parameter and it will return a double for you. And this is called explicitly casting, explicit cast or conversion. Here, let's say I have two integers, integer variable 1 and integer variable 2. I want this division to be a double division, so I say that make a new double out of this integer. So the first part will be a double over integer. Doesn't work, so the compiler will make a automatic conversion. So two conversions are going on here. This green one is this green one is an explicit conversion, operator based conversion. Okay, but the blue one is going to be an automatic conversion or implicit conversion. So this is implicit. Okay, this is explicit. I am explicitly saying that I like this integer variable 1 to be converted to a double. Okay.
Would you like to repeat this slide, please?
This whole slide, okay. Remember in C, when we like to convert an integer, okay, to a double, let's say 2, I like to convert to a double D. We used to do this, right? In C++, we don't do this anymore. We don't use this typecasting. We say static cast angled brackets double and 2, and we assign it to a double. Okay, and this is called explicit typecasting or explicit conversion. My pen is acting again. Okay, explicit. Okay, this is called the explicit conversion. Why? Because I am asking compiler explicitly to convert from an integer to a double. Okay, explicit conversion. Okay, we said that previously these kind of conversions were happening all the time. Okay, if you do this kind of mixed type arithmetic, And in that case, this 2 is converted to a double automatically by the compiler. This is called implicit conversion or automatic conversion, or automatic or implicit. Okay. This slide says about the this slide talks about the implicit and explicit convergence. It is not anything complicated. You have been doing this all the time using the old way of C way of doing it. Now we say that don't do this, but instead do this. Use this operator, static cast. Okay, it's a casting operator. There are other types of casting operators, and we will see them later. We will see them later. Maybe a question. Atakan has me a question. Can I change the value of a constant? You know, there is a funny operator, which is a bad operator actually. Const cast operator. Okay. You take away the constantness of a named constant, const cast, and you should never use this actually. It's a casting operator. It casts from a constant to a non-constant. Okay, don't do this. Okay, don't do this. Okay, there are a few types of casting. For now, we are only interested in static casting. Later, we are going to talk about dynamic casting, which has nothing to do with the this type of casting. Okay, I think Gökbey had a question. When we assign the value into a using mem copy, the value of the A will be changed in memory. So why do we need to return? Gökbey, why didn't you ask this question when we were there? I think I answered this. Did you get the answer for this for your question?
I think I didn't.
What? The answer was this. Did you understand now? If you don't return anything, how are you going to do this? How are you going to do this? What is the meaning of this A assign B assign C? First assign C to B, then whatever the result of this thing is, assign it to this, right? And I'm doing the same thing. First do this assignment. Whatever returns from this function, send it to this function so that it is assigned to A.
So this is for doing it multiple times. If you do it one time, do I still need to return?
Well, I mean, if assignment operator works in a chain way, concatenated assignment, this is called. And any type of function, if it returns something, I can use it anywhere I like.
Okay.
I mean, the assignment operator is defined that way. You are supposed to use your assignment operator this way. And if I like to do exactly the same thing with a function, yeah, I would do that. I mean, wouldn't it be nice to have 2 plus 1 plus 7 plus 9, something like that, right? So this should return something, and I will add it to this one, and I'll add it to that one. And assignment works that way too. Okay, so let's go back and typecasting again. 2 types of typecasting: implicit. This is implicit. It is implicitly done automatically for you. Explicit this is a C way of doing it. We don't like it. We don't like it. Instead of doing this, okay, we put a static cast at the beginning. Okay, same thing here, static cast. The old way of doing it still works, but we don't like it in C++. We say that this is a better way of casting variables, casting integers, casting constants between types. Okay. Again, this is an operator. Okay. Not all operators is implementable as functions because this operator, it looks like it is taking a type name. In C or C++, we don't know how to write those kind of functions. A function that takes a type name. Okay, good. Shorthand operators, increment and decrement operators. Okay, we all know that I plus increments the value of I by 1. Plus I increments the value of I by 1. Let's increment, okay, this is postfix, post increment, and this is prefix, right? Pre-increment. Let's write this function, let's write this operator as a function. Okay, a function post increment, it will take an integer. Well, in this case, since I am going to change the value of it, it looks like I am going to change the value of it. So I am going to take the address of a integer. So what should I return? What should I put in here? What should I return? What type should I return?
I.
Integer pointer.
Integer. I should return an integer. Remember where I would do such a thing? Let me make this a little bit smaller so that it fits. Here. Okay. And let me take this out a little bit down so that it fits in here. So I am trying to do something like this. Let's say integer I is 7. Cout I plus cout I. So this would write what on my screen? This would write
First 7, then 8.
It will write a 7, then an 8, right? 7 and 8. That's good. So I am trying to do same thing with a function post increment. Okay. So I am going to do this. Cout. Let me use my blue. Cout post increment. Okay. Address of I and cout post increment address of I again. So I like this to write again 7 and 8. Of course, I am assuming that at the beginning the value of I is 7. Okay. What should I write in here? So at the beginning, at the end, I have this return. I am trying to here I am trying to implement this post increment operator. Well, I know that.
Maybe
Yeah.
we will write a new variable.
Of type what?
Integer.
Okay, a new integer. Let's say it's a integer backup.
A or B.
Yeah, okay, B. Its value should be
Increment 1 I.
what?
Maybe that's okay. That's okay.
So
And
integer B is the value of I, whatever it is. Then maybe I should. Well, I know that I will return this one, right? Is that correct? Osman, is that you?
plus 1. B plus 1 return.
I should return B plus 1. This is post increment.
No. Sorry. Yes. Return B.
Oh, don't get too excited. That's okay. See, you may make mistakes. Okay. Okay. So I take a copy of the original I, right? And I return the original. But before I end my function, maybe I should increment the value of I by 1, right? Is this good?
Yeah, that's good.
Okay. So this is post increment, right? Post increment works this way. Post increment works this way. Can we do the same thing with the pre-increment operator? Pre-increment operator, I think we can. Let me do it this way and make it a little bit bigger. So I am going to do this. I am going to do plus I, and now it's not going to. So what would be the output of this these two lines now? 8 and 8, and I am going to write this pre-increment stuff, pre-increment and pre-increment, and here pre-increment again. Okay, so let me erase all of this part. At the end I should return something, I know that. Okay, clear now. Okay, so again, this one should print 8 and 8. So tell me, what should I write in here?
We don't need to new variable. Just increment I and return it.
Yeah, just increment I, exactly. I plus 1 and return I. Okay. So pre-increment is implemented that way, this way, and post-increment is implemented that way. Okay, good. So instead of defining how they work, I just implemented them. And I know these operators work that way. Okay, they are not that difficult to implement. They are not that difficult to use. And post-increment and pre-increment, which one is more efficient? I mean, in case you like to, I mean, the book says that, the book sometimes is wrong. The book says that this one and this one is exactly the same. No, it is not. The one of them is more efficient. Which one is more efficient?
Pre-increment is more efficient because there is no assignment.
Pre-increment is more efficient. Why? Because with the pre-increment, I don't take the backup, right? I don't need extra memory. Here, I need extra memory for B, for the backup. Here, I don't need the extra memory, right? I just increment it and return it. Here, I need to take the backup of something. So pre-increment is more efficient. That's why they usually tell you that if there is no difference for you between these two, just use the first one, pre-increment. It's more efficient. But the compilers are smart enough. Okay, if you use it this way, just I plus plus. Okay, this looks like 7, but it's plus. Okay, if you use I plus plus somewhere, compilers are smart enough to ignore that taking backup stuff. But anyway, plus I is more efficient. Okay, so For the post increment stuff, the book says that int variable plus plus uses the current value of the variable, then increments it. It is wrong, right? It is definitely wrong. Why? Because for the post increment, we did this, okay? It first increments the value of I, but it returns the unincremented version. So incrementation is done at the beginning, okay? Incrementation is done at the beginning. But the return value from this operator is the original value. So doesn't matter what I do. Let's say A gets the value of 7 plus B, or A gets the value of 7 plus B plus plus. Doesn't matter. The first thing that's going to be done in these two expressions is to increment the value of B, and increment the value of B. The value of B is incremented, but this plus plus B operator will return the incremented value. This one will return the original B value. Okay? So when the book says uses the current value of the variable, then increments, this is wrong. Okay? B is incremented at the beginning, but the return value is the original value. For the pre-increment, okay, increments the variable first, then uses the new value. Okay? So be careful about this. We are gonna return to this one when we do the operator overloading chapter. Okay? And that's going to be different. Okay, Mehmet Hussein has a suggestion. He says that I would increment the value of I by 1. By the way, Mehmet, is going to be dereferenced I plus 1. Okay? It's not going to be I plus 1. Dereferenced value of I. This is not a good idea, Mehmet, because sometimes the meaning of plus is very, very different. So you don't want to both add and. What you are doing is doing one addition and subtraction. This is extra work. And sometimes the cost of that subtraction might be too much. Okay. Good. Let's move on. There is a stupid example from the book. Well, it is not any more stupid than my examples, but the value of n is 2. The value produced is uninitialized. It says that value produced is 2 times n plus plus. So that means that somebody is going to return the value of n first. So the value of n is 2. 2 times 2 is 4. So value produced will be 4. But before returning the original value of n, it will increment the value of n. So it's going to be the value of n is going to be 3, 4 and 3. But if I do it the other way, this one is going to increment the value of n to 3, then it will return the incremented value. 2 times 3 is 6. Okay, so I did that too. Good. If there are no questions, I will skip to a new kind of topic, console input output. For now, we have used C in and C out. C in and C out. These two objects, or variables if you like, they are all defined inside this header IO stream. I showed you where they are defined, right, last time, using the -E compiler switch. Okay, so C in and C out and -E. I showed you the definitions of those. There is another object, it's called C error. This is character out, character in, and character error. If you wanted to print error messages to the console, okay, you don't send it to C out, you send them to C error, so that it goes to a new stream. Okay, and it is defined inside this IO stream too. So, okay, you do this. C out, enter positive integer, enter a positive integer, okay, and then cn, let's say a. If a is less than 0, then you will say C error, input error. And then exit -1. Okay, so this C out is regular, your regular standard output. This is error output. Sometimes you like to keep these two separated, two different things. Okay, that's why you have your error output and the regular output. Okay, so it is available for you. Okay, so what would you, so how, okay, let me go to my Ubuntu stuff. Okay, so usually, let's say, do I have my, okay, somebody has written this program named ls, right? When I do this ls, okay, when I do this ls, it sends all the output to the console. But if I like to redirect it, I can, if I like, I can redirect it using this. I like to send the standard output to a new file. It's named output.txt. Okay, so I didn't see anything because everything is sent to this output.txt. When I list it, it's output.txt is here, and if I like to see what is in it, as you see, all the directory listings are listed in there, right? So I am redirecting the standard output to output.txt. How about this? If I do this ls abc, it says that I don't see any file named abc. It's an error message. It's an error message. So what happens if I do this? If I do this, see, I am getting the same error message on the screen. It is not redirecting to error.txt. Error.txt is going to be, there is no error.txt because ls did not produce any output. So if I like to redirect my error stream to error.txt, I do this. See, now I have error.txt. Where is my, here there is error my txt. If I just cat it, okay, here it is. So you may redirect your standard output, error output to different files, but if you like, you can do this. Okay, if you do this, if I can find the ampersand sign, where is the ampersand sign? Here, can find it. This one. Oh, I found it. Okay, this one will direct everything. Okay, this one will direct everything, including standard output and the error output to error.txt. Okay, so these are all defined in your bash documentation. I am using this shell, bash shell. Okay, if you read bash documentation, the manual page, you will see all the details are there. Okay, it's a very long documentation. If this is not clear enough for you, just read the online documentation for bash. Okay, so for the console input output, You may do anything you like printf and scanf. Okay, you may output variables, constant, literals, and expressions, doesn't matter. So this one says that I'm going to print an integer, then I'm going to print a string. Okay, or you may, if you like, cout result is 7 plus 3. You may do that too. Expression. Okay, so this stream insertion operator can handle all these kind of different types of variables, this different type of output stuff. This is called console output. And this is called cascading. Okay, see, I have two things. One stream insertion, second stream insertion. In structure, it is very similar to this. A assign the value of B, assign the value of C. One difference though. Somebody tell me the difference between these three. A plus B plus C. Cout, stream insertion results, stream insertion 7 plus 3. Okay. A assignment B, assignment C. Do you see any difference? Let me get rid of this one and so that it is. Yes.
Assignment is right to left, cout is left to right.
It's not cout, it is a stream insertion. Okay?
Yeah.
Okay. Operator. Okay. Plus operator, associativity for the plus operator is from left to right. Stream insertion left to right. Assignment is right to left. Okay. Assignment is right to left. Why? Because if they had chosen assignment operator associated left to right, then you would do this. What would you do? Assign B to A, right? And the return value of B, which is a constant, then on your left you are going to end up with a constant which is not an L value, it's going to be an R value, right? So it is more logical to do it this one first. This one will return you a constant and you will assign that constant to this L value. Okay? So that's one difference between assignment operator associativity and the other operators associativity. Okay, so we already know that new line works there. Sometimes they say that instead of using new line in C++, we use end of line. Okay, end of line is very similar to cout. I mean, in terms of its usage, it's an object, but it's a very simple object actually. Well, it is not defined that way, but let me tell you how the constant character end of line, the value is this. So somebody has written this line in stdio, okay, or sorry, iostream.h. So the definition of end of line is very simple, something like that. Some people say that don't use this \n, it is a C thing, and we say that no, well, this is good enough. Okay, good. And then we have in C++, we have a new type name string. Well, actually, it is not a part of, again, it is not part of C++, it's the part of library. It is included using this header include string. And it is much more convenient than what we had in C. You may say, I have two strings, string A and B and C. The value of A is hello, okay, and value of B is bye. See, the assignment works very nicely for the string. And I can do comparisons. If A is equal to B, then C out C. I could do this kind of stuff. With the character arrays, what would you do? You would say a character array A 20, B 20, and C again, let's say 30. I have to specify the maximum number of characters in there. I cannot do A assignment something, right? You have to say str copy A comma hello, right? I have to do this. I have to use a function, or I have to make a comparison. What would you do for the comparison of two character arrays? You would use str
Comparison, CMP.
strcmp, right? You would say if strcmp A comma B, etc. So instead of doing this in C++, they say that why don't you use our new string type? Okay, and everything works. And in fact, this plus operator works too. This plus operator works too. Let me again. I wrote too big. I am out of time, but you're not going anywhere anyway. Okay, I could say C out A plus B. A is hello, B is bye, so this one will print hello bye on my screen. Even this plus operator works. Assignment operator works. Plus operator works. So this is very convenient. So from now on, use this type string in your homeworks or in anything that you like. Don't use these character arrays. Okay. Of course, we are gonna do comparisons from time to time, but using the strings is much more convenient than using the character arrays. Okay, so I think I will stop here. Tomorrow morning we will continue if there are no questions. Any questions? So read the homework today, okay, and learn that game, the game of hex. The class is over, okay. If you like to go, you can go. There is a play hex online. When you say play hex online, I think I was playing with one of them. Which one is this the JavaScript? Yeah. Okay. Good. Okay. We are not going to use the swap rule. Okay. And I think I am playing the red. Okay. I start here. It's very smart. I am not an expert of the game, but it looks like so. The idea is connect from this side to that side. Reds, blues are supposed to connect it that way. Okay, so if I just do this, okay. Now it's going to cut me from there. That was a mistake. Okay, I will do this then. It's not going, no, okay. Now I'm going to play in defense. If I do this, okay, no, okay. I think I'm doing good. If I keep doing this, wow, okay. Do this. If I do this, that's going to be bad.
Blue will win, maybe.
I don't think so because there is. Oh, okay, yeah, he got me. Yeah, the blue won. It's difficult. I just learned about this game, so of course your game will not be as smart as this, but all of your moves should be valid moves. Okay. And when the game ends, your program should know that the game ended. Okay, So the first you're gonna use your C programming skills to make a nice C program. Then we are gonna change it to a object-oriented programming example. Okay. And try to learn how to play this game. This is very smart. Okay, good. What do you mean, Serdar? Good job, sir. Just he beat the crap out of me. What do you mean? Okay, I'll see you tomorrow.
İyi.